Hello, everyone. Welcome to the latest Clojure workshop before the Clojure conference. Today's presentation is a deep dive into XTDB with Jeremy Taylor. Jeremy works for Juxt, a huge contributor to the Clojure community. So XTDB used to be called Crux. It's been renamed and rebranded. Love the new look. I heard that a new version of XTDB has just been released, so it's being actively developed. We also have quite a few XTDB users attending today. So XTDB is described as a general purpose immutable database with graph-oriented bitemporal indexes. So that's quite a mouthful. Hopefully we'll get some insight into exactly what that means during the presentation. So welcome everyone to the workshop. And with that, we'll hand it over to Jeremy Taylor. Take it away.
Hey everyone. Thanks for joining. It's great to see so many people interested in what we're doing with XT. I do just call it XT for shorthand, by the way, because XTDB is easier to read than to write, or to say, and to write. Anyway, so I gave a, well, we did a talk last year at Clojure, and I also gave a workshop, and last year's workshop was 3 hours, and I spent a lot of time looking at Datalog and graph queries and this sort of thing. But this time I have more clear objective to just focus on temporality and what makes XT fairly unique, not just among Clojure databases, but amongst all databases. And just to set the scene before we get into the REPL, I would like to run through a few slides. So I hope everyone's got sort of 10 minutes to digest this before we look at some code, because I really want to make sure we're all on the same page. And of course, there's a lot of people with different experience levels. So why would someone build a database? I think there's a prevailing view amongst developers that databases are sort of done, or at least they're good enough. They get the job done. They're just a place to store bits durably on hard drives, maybe in a cluster, but once everything's backed up and replicated, like all the clever stuff is in the application layer. And I think that view is dangerous, almost. It's like sort of complacent to think that databases are a solved thing. I think the market as it is underserved, and that's because they're incredibly complex pieces of software to create. So let's talk about why Juxt created a database. Now, it wouldn't be right to not mention Datomic, huge influence on what we've done with XT, and myself personally. Rich and the team have gone through a lot of these problems and extolled why mainstream databases are inadequate for solving value-oriented design, with a big focus on place-oriented programming. The inability to query over consistent points in time means that your systems get very complicated. Datalog was created as, or reimagined as, like an easier query language, which is debatable, I think, even though it is quite elegant and powerful. We'll come into a bit more of that. But on the other end of the spectrum, SQL is this massive standard and no one implements it fully. And it's very expensive to create a new database that implements SQL. So the marketplace of databases is quite chaotic, really, and I don't think represents any sort of coherent vision of what databases should look like in 20 or 30 years. And there's a lot of startups over the last 10 years focusing on building new database technology, but arguably solving a lot of the problems which maybe lower priority than others. Yeah, I just think the energy required to get a new database off the ground means that there's very few experiments. The world needs more databases, more innovation, more people trying to figure out how to do things. So one of the views of this is, given a piece of database technology, a DBMS, database management system, like what does it do that increases or reduces the incidental complexity or accidental complexity in our systems? And in XT, we think that time is like a very key dimension, which if not addressed early in an application lifecycle by like getting it right at the database level, you're going to introduce a lot of accidental complexity, not just within the one application you're building now, but over time as you integrate with other applications, because time is so pervasive. So one of my favorite examples is thinking about retail. I think it's like a very easy domain to think about. And rather than historical data, let's think about future data. Let's say although these timestamps are in the past, but let's say we're putting data into the future to try and plan some activities on a website. You want the products to go live at a certain date, and you want the promotions to correlate, with those products going live, but maybe not at the same time the product's introduced. You maybe want to give it a week or wait until Black Friday for the promotions to kick in. And then you have these vouchers which are valid, for the life cycle of the promotion, and then you want to sort of remove them from the validity to say, no, this is expired now. And there's all kinds of ways you can model this in a database. But the point is that if you want to do it justice, you're going to have lots of tables with lots of valid from and valid to columns. And this is just unnecessary complexity to have these timestamp columns, and the way they complicate the SQL queries. Even if you have SQL 2011, it's not easy to reason about. And one of the reasons why XT works the way it does is it sort of says, well, let's move away from like strict table oriented thinking. Let's move away from relational schema modeling as classically thought of with existing SQL databases. So what bitemporality is, to be sort of very short, is on the one axis you have like the audit timeline, the transaction history timeline, and this gives you the consistent snapshots, and it gives businesses the ability to say that someone tampered with the system or they didn't. And then on the other axis you have this mutable view of time, which we call the validity axis, valid time axis, also known as application time. And if you read, say, the SQL 2011 standard, they talk about application time and system time. But essentially, this two-dimensional view is the way to think about it. And what XT does is it allows you to take any point on that plane, on that 2D space, and say, what is the value of the database at this point? And that allows you to answer two kinds of questions. What is the state of the database, the physical state, and what was it the physical state yesterday? But then you're able to ask these sort of model level questions, where you say, what was the state of the world based on information I learned 5 minutes ago? What was the state of the world yesterday? So this flexibility in the valid time history gives you the ability to backfill data, to ingest out of order data, and to correct history. But as we just saw, also to put things into the future, to sort of schedule validity. So these are some key use cases. And from a view of why XT was created, it was really to solve this problem of out of order events, and then the backfilling of historical data from upstream systems. So where you have data sources which are in different geographic locations, you would need to integrate them into a sort of common view of time. And again, you can plot these on axes, and I'd like to spend a little bit of time looking at these sorts of diagrams today. So XT postulates that bitemporality is like a good foundation for thinking about data, and the ability to efficiently query across those bitemporal axes. It's no good just sort of replaying log files and waiting 10 hours for a database to spin up so you can query at a particular point in time. You should be able to navigate through the indexes efficiently and express those queries efficiently from the application perspective. But given bitemporality is like an always on thing, you shouldn't have to think about it until you actually need it. So all the APIs are geared around you're just worrying about now. And should you realize, actually, no, now I need to the company has bought another company, and now I need to integrate these two core data systems, like an ERP setting. Like, until you face those problems, you won't have to think about it, but that's what it's there for. which is why we call it sort of general purpose, is because XT, whilst it's designed for this, we don't think it should only suit people that have like an immediate application level bitemporal use case. So we implemented Datalog with XT, which is like a recursive logic language, which allows you to navigate the graph of entities in the database. And so instead of thinking in sort of relational tables which join to each other in like an entity relationship diagram, we think of things as more of the sort of universe of triples, which you can join and navigate in any direction. So Datalog has, or Eden flavored Datalog, as seen in like DataScript and XT and others, has these EAV indexes, and that's sort of a general pattern, and they allow you to do these traversals. We call it the triple clauses. They're a type of clause, and you have other clauses which maybe are like predicates or function expressions, which allow you to transform values. We implement binding and pattern matching to make expressing certain destructurings or subqueries possible. We have rules, which are fairly fundamental aspect of Datalog. So you can do like graph-like traversals and have rules that are mutually recursive as well, so they can call each other, and the engine will sort of figure out how to do that and expand the current in-memory set. And you can implement custom predicates. So where Datalog does fall short of SQL, how do you do an aggregate, which is this weird, funky thing with windowing time? Well, you can always fall back to Clojure or another JVM language and have sort of first-class support for transforming data to then go back into the query and do the rest of the querying. So it basically gives you a way to blend query language and programming language. So I just see a question, so I want to pause for a second, take a breath. So the question is, what's the practical overhead of XT's immutable data? Can it handle thousands of large records, e.g. 10 megabytes, each updating in real time, dozens to hundreds of times per day? Also glad to rethink my assumptions for to GraphDB is bitemporal. Blah, blah, blah. Okay, cool. So practical overheads. I mean, there are no fundamental limitations in XT, like you can put different size documents in. So I haven't got to talk about documents yet, but documents can be very large and they will work. I think there will be an upper limit as you reach the limits of like memory usage and that sort of thing, but there's no hard coded limits. So I think the answer to these things is always to come up with a small example and just measure and test. And then if you have issues, like send it to me over Zulip or Clojure in Slack, or raise an issue, and someone from the team will be happy to just sanity check what you're doing to see if performance can be tweaked in some other way, or you can adjust the modeling you're doing. But inevitably there are practical overheads. I'll talk a little bit about the index structure and how that works, so you can get a feel for it. There is some structural sharing going on. It's maybe not as comprehensive as it could be, but in broad terms, if you're updating like a single large document, like thousands or millions of times, it's probably an anti-pattern. You want to break out the things that are actually changing from the stuff that isn't changing into separate things and join them back at query time. Cool. Okay, and I see, thanks Mark for posting the out of the topic paper. Cool, right, next slide. So what XT's done is to take the Datalog that a lot of people may be familiar with already, and applied it to a document graph. So instead of having like a very concrete schema which talks about entities with attributes that have cardinalities and adding and retracting triples, we think in terms of documents, which we decompose into entity attribute value triples. And this has various positives and negatives, but in general, we think it's like a simpler thing to reason about and certainly to implement when you also think about the fact that XT doesn't have a schema, so you never declare the cardinality of an attribute. And also once you have bitemporality, the combination of schemalessness and bitemporality basically makes it intractable to have like a generalized alternative to this system, although I'd be very happy to debate it with someone. Explicit IDs is another thing that XT emphasizes. So if you want a UID, you generate it upstream. If you want a URI, generate it upstream, and then XT doesn't try and generate IDs internally. Again, it sort of simplifies what needs to be done in the core of the database engine, and means the user has more control. We use hash-based comparisons, and I'll show this in the workshop, which means you can join things dynamically. You don't have to say this thing is like a reference type attribute. If two values match or a value and an ID match, you can join on those like links, even though they're not really links, but they're sort of next to each other in indexes, so you can traverse them. So that, yeah, gives you dynamic references, and those values that you can traverse are sort of arbitrary. So we use NIPI under the hood, which allows you to serialize almost any object you might have, and come up with a binary representation, and then we compare the binary representations. And then our rules have like hints, which mean you can say what variables should be bound or not. And there's a few other subtle differences. And for those who haven't seen this architecture diagram before, I'll just run through this really briefly as well. So transactions get submitted, and they don't go to indexes immediately. They go to the transaction log and document store. And these are like centralized components which can be shared amongst any number of nodes. And then the nodes pull from the transaction log and document store to materialize the indexes. The indexes really are like a materialized view over the transaction log and document store. So nodes can be destroyed and brought back to life ad infinitum, as long as you never mutate or sort of delete the documents in the document store or the transaction log. You have an immutable system there. So that's the overall design, and we use embedded indexes like ROX or LMDB. But I know a lot of people will have still many questions about how that works and how the design can scale to different levels. Like, what if you just want to use XT in a small like desktop application versus if you want like the biggest, beefiest, fastest clustering system with Kafka or what have you. So there's a whole spectrum of things, and I just spotted a typo with crux there. Or didn't change it to XT. But the point is that you have a whole range of configuration options, and this is roughly in order of simplicity of configuration or getting started versus scale. So a lot of people have access to a JDBC-based database like Postgres or MySQL, but we, if you want this sort of ultimate performance, like Kafka is unbeatable in certain ways, as is having like a local document store, which is like a fully materialized cache. So a bunch of stuff there, and I'll just run through the architectures so you get a flavor of that. So rather than viewing it from the architecture diagram level, view it as like a layer of design choices. So transaction log is at the foundation. It gives you this immutable guarantee and ACID. So as soon as something's committed to the transaction log, it's been saved to disk. So that's an important quality. The documents I've mentioned, they have, as long as you have an explicit ID and it can be serialized with NIPI, anything can go in there. Obviously, don't recommend putting video files in, but it could in theory work at least. Yeah, the other key thing is that the attributes need to be, well, essentially Clojure keywords, although from a JSON perspective, strings, and we have a JSON API, but the values can be arbitrary. So these two components support as many nodes as you like. They can be at different versions of the index, so people could have like different departments in the same company could run their own nodes with different versions all running concurrently, like different XT versions. So they might have slightly different index structures, and they can scale them out independently. There's a checkpointing system as well. So if you want to spin up a new node quickly, you can use a checkpoint rather than having to replay the log from scratch. Although if you're doing like an upgrade, you would need to replay them. So then each node has an index store. An index store is like a set of graph and temporal indexes which take all the data, and they are more or less covering indexes, although there are still use cases where the document store needs to be refetched, certainly for large values. The index store tries to be a little bit lean and not have to replicate all the data. But yeah, the RocksDB or LMDB storage engines use prefix seeks. That's like a very fundamental operation in XT. So the ability to jump to, maybe not, if you don't know the key, you might know the prefix of the key, and then you can go to like the next value that's in the index. So that's like a very important thing. So if you're thinking, oh, what else could I use as an index store? Like I've implemented a Redis module, so that would work. But RocksDB and NumDB are fairly optimal at what they do. Cool. So we have a bitemporal index. So we actually have two. One is the timestamps, literally like valid time, then transaction time, then the entity version as like concatenated strings. And the other one is like a Morton index, which has like a bit interleaving. Like a Z-order curve is the other expression, like a Hilbert curve, but different, which allows this sort of multi-dimensional compression into a single key. And this is used for tracking or querying the currently visible document. So as you're traversing the graph, the query engine is analyzing, is this thing currently visible? Is this thing currently visible? And it will cache that result as well. But essentially every traversal of the index also involves looking up the bitemporal index. But the benefit of this is that the lookup is like equal across time. So whether you're looking at something very old or very new, the query should run approximately the same. But it does mean there's a small tax as well to query something that's current. There's no sort of hot path for what's currently visible. Okay, and then we have the triple indexes. So as like these are like atemporal, so they don't encode any of the timestamps or the versions beyond like a version hash, but they allow all the Datalog to execute in an efficient order where like the different clauses get rearranged and interpreted by the query planner using statistics to create this query plan. And it may not always be the best possible query plan. So there's a certain amount of having to understand or infer the operation of the query engine. But at least it works, and it doesn't have any requirement to define the schema up front. So these indexes are completely generic. And on top of this, we built a query engine, which uses this sort of worst case optimal join like algorithm to lazily iterate through all of the various combinations of logic variables in the query to produce results. And so if you have a very large graph query, but you just want a few results, you don't want the entire result set, it can be quite efficient. And also it minimizes the amount of working set memory usage. So it doesn't materialize entire clauses one at a time, like other more popular approaches. And it's got a query cache as well. And then, so yeah, then we have this Datalog level where we've provided this Eden-friendly API. And I guess a key thing to note is the clause ordering that you provide is ignored, and the engine will pick one that it thinks is suitably fast. And that's like an argument that Datalog should be declarative, so order agnostic. And then the support for subqueries and aggregations, which are implemented as like fully materialized subqueries. And so as an example of what does worst case optimal join mean, you can do things like, given a graph of bank accounts, find like these cycles. So you don't know which one to start with. So all you know is that there are these cycles out there where fraudulent money transactions are being sent around. So that's like an example. So that's kind of what this algorithm is absolutely good at versus more traditional relational like volcano model execution engines. But yeah, that's just like an insight into some of the things it's uniquely good at. And then, of course, we have these other layers like an HTTP server with OpenAPI, and we have a full text search index as like a secondary index. So rather than just saying your entire data model must fit inside this like triple index, you can customize this secondary index capability to, I want to index product description strings, but not product titles, or I want to use these keyword analyzers and this sort of thing to do these real-time lookups and then merge the results back in with the Datalog. And then we've also got a SQL API for Calcite, which is like a mechanism that allows us to compile this Calcite SQL into Datalog dynamically, which has some interesting properties. And I won't talk about the roadmap too much, but SQL is sort of firmly a big part of our roadmap looking ahead. And then I just want to say, in case anyone's interested for reference, these are the indexes. So if you ever want to come back to this, it's also in the codec.clj file, but explaining how these work exactly. It would take a lot of time, but if you ever wondered, which indexes does XT have, you can look in there, and these are the important ones. So you can see we've got the different orderings. So like an EAV triple is also indexed as an AVE triple, but also as an AE and an AV. And then we have this idea of a content hash, which is an NC at a point in time. All right, I'm going to pause for a minute and ask if there's any questions on any of that. Otherwise, we'll kick off with the meat of the workshop. Cool. All right, so for the workshop, I have prepared. Daniel posted a video I saw the other day on, where was it? I think it was just Clojure in Slack. And it was about the, so I'm just going to stop sharing a second. If it'll allow me. My window manager seems to be broken. Okay, I'm going to shut down Chrome because I think it's died, and then restart. So I'm going to just refresh this. So okay. So Daniel created a video the other day, and like I watched this and I was like, hang on, this is, well, I've got adverts, but there's Notespace video about like a notebook experience in a Clojure namespace, and I thought this is a really interesting thing. So I spent like 5 minutes playing with it. I was like, this is too good to not try and use. So I've adapted all the content to work in this format. So what you can do, everyone out there, is either use this repository, and I'll post this link here. So I'll post it in the chat. Yep. That should say 21. So you can clone the repository and fire up your own REPL, connect to your editor, and we'll take it through from there. So I'll give everyone a moment to do, or 30 seconds to try and do that. And maybe if someone is definitely doing it, just maybe say hello so I can know that someone is following along, and we can gauge how useful or problematic it is. I already, of course, follow these instructions and have a REPL available here. So it's yeah, as if I just cloned the repo and started a new REPL, but I have evaluated the namespace. So I'll give it one more moment. All right. So the idea with this view is that we're seeing like a visualization of this entire REPL. So all this stuff is in the REPL, and this menu bar at the top is like an index, so you can quickly jump to separate sections, and it avoids us having to scroll for ages and ages. So it's quite a nice design. But we can look in our buffer on the right and just sort of scroll down and start evaluating things. So I'm going to save the file, which will sort of clear all of the evaluations to make sure that's good. So we have this restart command, which you need to run first. And once you do that, you should see a message in your prompt saying 1903 is ready. And then you can open up this, and I'll just refresh this again just to show you what it looks like. So it remembers your last position. So assuming that's what you've got, we can walk through this. So setup. So I've got a bunch of dependencies. So obviously XT, so this is the XT core namespace. There are loads of other namespaces and modules, but we only need one to get playing with today. And then we're using the Notespace namespace and also one of its sibling projects called Kind, which allows us to visualize Hiccup. And then I've got a couple of other extra namespaces, which we'll discuss in a bit. So with that all working, we can now go into usage. So I won't read all this out verbatim, but essentially it's a balance between like, in order to evaluate stuff, you can just eval in your buffer and the results will be displayed on the left. But when you save your buffer, the browser refreshes because it's watching the file system, and it like populates any modifications to forms that you make. So if you've just modified a form and then you eval it, you may not see the result because your form is different to the one that was on the browser. So you have to save first and then eval, and then it should come up. And I'll go through that, and there's some notes there about things I've learned trying to use this. So if I want to like add a form here, so 1 + 1, and I try and evaluate this, I'll get 2 on the right, but you won't see it here because it hasn't sort of populated the view on the left. But if I save, it shows up there, doesn't put the result in, evaluate, and now it shows the result is 2. So that's basically how it works. But the key thing that I really like about this is that you can visualize Hiccup, and in particular, I want to do some SVG rendering today, so we can evaluate this and produce a nice blue square. So that's one way to think about this tool. Is it's a nice visualization tool, but there's also various built-in things. So here we can see we can randomly generate these plot lines, and the actual data being passed back is this, Hiccup with an embedded data list. But we're able to render it into this nice view. We're not using anything quite that clever, but hopefully gives you some inspiration as what's possible. So next we want to start XT. So if I scroll down, so by default we have an in-memory node. So if I evaluate this, it doesn't actually produce a result, and I think def doesn't add anything here. But if we do type n, we can see that we've got a type, and this is a Java type XTDB.node, XTDB node, and this allows lots of Java interop, which is good for the non-Clojure users. And now we can run like a status command and see we've got the latest version. So we released this 2 days ago, and yeah, so there's some bug fixes from 1.19, but it's broadly the same feature set. And like not everything in the map is that relevant. Like this is kind of only relevant if you're connected to Kafka. But crucially, we can see we're using an in-memory database, which means as soon as we lose the reference to this node, that it's going to be garbage collected and we'll lose all the data that's in it. So be careful, and when you're done with the node, you can close it because it implements closure. Cool. So other key things to note. It's embedded in the process, so there's various threads and things going on in the background. But it means that there's no barrier. You're not going over an API, like a remote API, RPC or anything. The actual implementation, if you were to poke around, there's a lot of caches and things created, and there's off-heap memory structures. So comparing this in-memory node to say data script is probably not very fair, but we could potentially look at some examples there. And yeah, that's the other key thing. So this node is not visible, or the data in this node cannot be visible to other nodes. So nodes are designed to be completely independent, except via mutually hitting the same transaction log or document store. And because this one embeds its own in-memory transaction log and document store, it can't then expose those to other nodes. But doing so is not necessarily complicated once you have a persisted transaction log or document store. Cool. So that's starting. I'll pause for questions. Quick look. All good? Great. Okay, so next up is let's look at the basics of the API. So if I scroll down, in order to query the database, you first have to create a DB value or snapshot, which in XT's case does actually open up some underlying resources like IO resources. So if you're using RocksDB, it would be creating these C++ like iterators, which is it's not like a completely cheap operation. But the idea is once you have a DB, you can fire lots of queries at it and be guaranteed that that's always going to hit the same caches at the same point in time, which gives you repeatable reads. So if we want to run this here, we'll see the result. So this query has used the query function, takes the DB value and a Datalog query expressed with a quoted form, so that these E symbols don't try and get evaluated because they are representing logic variables, which don't have values. So the result we get back here is a set, which is great because there's nothing in the database. I'd be shocked if it did return anything. And if we want to submit data into the database, we use the submittx API, which takes the node and it takes a vector of operations. And here we have an operation put and then a document. So as I've mentioned, a document is fairly arbitrary. The only key things it has that needs is an explicit ID, and all of the top level keys need to be Clojure keywords. Otherwise it'll reject it with a spec error. So yeah, and there's another key point here, which if the values are composite, like a set, so if this 1, 2, 3 was a set or a vector, XT decomposes those into individual triples. So bear that in mind if you ever come across it. But we won't focus on that. So the other key thing is submittx just there returned this map back, and this has an ID. It tells us it's the first transaction and the time. And this time is governed by the log. So if you're using Kafka, it's like the broker time, which is important because this is what gives the whole thing consistency, is these two things. But once you've got that information, what that's basically saying is that the data has been submitted, but it's not necessarily ready to be read. So in order to know that the index has caught up to the latest point in the log, we can call this function awaittx, so in this example, I'm resubmitting another map. So this is bar, so foo was up there, bar's down here, and we're awaiting the state of the node to have caught up to at least the submitted transaction here, or the result from the submitted transaction. There was one other workaround caveat with using note space, and that's if you have identical forms, I've noticed the evaluation goes to like the first form. So to bypass that, just change this number to 9 or whatever if you're going to be repeating these forms. So if I run it now, we see that now we have bar and foo in our database. And yeah, crucially, we haven't added any schema. This is just stuff, documents flying in. There's no real complexity here. And the indexes are populated. So as we get to a more complex example, you'll see that the numbers, for instance, are stored and traversable as graph indexes. And if you want to pull out not just the IDs of these documents, but the full document, we could pull them out using pull. Like there's a pattern language which is based on the Eden query language, which if you've not seen as a nice new logo, and we implement that as like a standard spec for it, which works quite well. And if we wanted to pull out, say, both the, like you can add multiple things in find here. So you could do hit my main rule. So I had to save the buffer and then evaluate. But you can see we're able to pull out a set of tuples, and the tuples correlate to what's in the find vector. So here we're pulling out E and E, and then we're pulling out the whole document using this star, which is a wildcard saying, get me all the attributes. And we could also use the entity API to get like an entire document. And this bypasses most of the indexes altogether. It still uses the temporal index, but it will go straight to like a document cache. So there you go. That's some basic stuff on the like the APIs you need to get going. So again, I'll look at chats to see what's going on. All good. I needed to require conform as conform. Interesting. I'm not sure why that is, but thanks for figuring it out. Like I don't think we're using TX conform. Oh, I know why. That's because in this guy, I was using it here. Conform. Yeah, I was using it here. Okay, sorry about that. I didn't prepare the repo properly. And hopefully that evaluates okay. So yeah, we'll go to joins next. So the idea of joining in Datalog is almost it's like a fundamental thing. So whenever you have multiple clauses and you repeat the logic variables in multiple places, you're always going to be joining those instances of those logic variables together. You can think of it a bit like simultaneous equations. So what the engine is doing is finding sets of combinations of values for those variables. So in this example, we know the documents we just put in have a my number. And in this case, we can use a literal in the triple clause to say, I'm particularly interested in that one we just submitted foo. We could also parameterize this and have like there's a thing called in bindings, and you could say in, my entity ID, and then you could pass my entity ID in like that. But for simplicity, we'll just use the literal, and then we're generating a new logic variable, my num, and then we have it again in the second clause. And so what that's doing is joining these two clauses, or the use of the variable in the two clauses together. So in order to find e's, those e's have to have a my num which matches the my num of foo. And I wonder if anyone knows what the result might be, but you get two things back, and that's because foo itself is like a valid entity in this position. But you also get bar, of course, which is the one where that proves that the join worked. And it works, as I said, because we have these indexes. Looking at the left rather, we have something equivalent to entity plus attribute, get me the value, which is the sort of naive ordering, the forwards graph traversal. And then to do this reverse joining, we need to give them that attribute and a value, find me the entity. And so in the indexes, we have these, essentially something like this that's stored in binary form on disk using RocksDB or LMDB, or in this case, in like an in-memory KV data structure. And I forget what we use. It's like some Java sorted map thing. And another key difference is versus other Datalog databases is that we don't support arbitrary or wildcard attributes, and that's partly because of the simplicity of the engine. Like it would add a lot of complexity to make it work, but also like in most applications, or can at least enumerate the possible attributes. And in the worst case, we have an API to give you sort of all the attributes that are known. So we have, what's it called? Stats, attribute stats of the node. And if I save this, we can call it and see. So across all my documents, across all the time, it gives me the list of attributes that are in the database. So it's at least useful for gauging the population of the database and seeing what might be there for querying. Cool. Right, next up, temporality. So the model that XT uses is that you can think of each entity's timeline in an isolated way. So entity A will have its own history or set of versions in a history. Entity B will have its own versions in a history. Entity C will have its own versions in a history. And when you query the database, the engine can combine all those histories together into like a global history view. But when reasoning about what is the version of a given document at a point in time, in the simplest sense, you just want to focus down on a single entity. So here we have our foo document, and if we want to submit some information to it, we can. So we can say I want to add the color red. So it's just an arbitrary thing. It could be my favorite color. Doesn't really matter. And now that's in the database. Oh, sorry, I didn't show you this. So this is just a little helper just to avoid having to use await tx, because XT is inherently asynchronous. This is not necessarily something you want to do in your production code. It really depends on your use case, but you can use the sync function, which is more complex than await tx because it actually looks across. If you have multiple nodes writing to the same log, it will look at the latest write and then use that as like the await. Yeah, it's like await on steroids. Anyway, it guarantees that the index is like as up to date as it can be. So in this case, we're submitting, we got a new transaction result back. I don't know if you saw that, I'll do it again. Yeah, transaction time 3. And now we can look at the entity history of foo, and it gives us this. And so I just submitted the same thing twice. And it's not actually trying to show us the content hash because it's using an XT. What do you call those? Just like a custom tag, literal. So it's not displaying on the left. But if we want to see what the document looks like, you can add with docs true, save that, and evaluate. You see the actual versions in here. So that was the original version we submitted. When was it? About 10 minutes ago, and then a minute or two ago, and then a few seconds later. So those are the 3 versions for this one entity. But we can also, yeah, as I say, put information elsewhere in the timeline, so we can backfill the version of the document in the past. So yesterday, December the 1st. So we could say yesterday my favorite color wasn't red, maybe it was green. So I'm going to save that, submit. Where did it go? So yeah, so transaction ID 4. And now if you want to view the entity history, we see there's now 4 things in this history. So we see that green now comes before the first document we put in. So it's sorted first by valid time, so 1st of December, and where it needs to, it will tie break by transaction time. So that brings me on to corrections. So if I now want to say, actually, on the 1st of December, my favorite color wasn't green, it was actually blue, I can submit another transaction. And I didn't clarify, actually, when you put as one of the transaction operations, the start valid time is like an extra parameter you can add. There's also end valid time if you want to sort of put something into a particular slice of history. Otherwise, it will automatically stop at the next change, or like the next entry in the history log. So there's some corner cases there. If you've got lots of deletes and things, because it sort of puts in like a nil tombstone. But I won't get into the ins and outs of the history API, or like all the semantics. So now we can view again the history, and we see, so red is gone, now it's replaced with blue. Sorry, green is gone, it's being replaced with blue here. But that's because we're looking at the database as of a point in valid time and transaction time. So because we're supplying a database here, it's by default like just looking at a single point in time. If we want to see what the previous versions in transaction time were, so like show me what things were before the corrections, we can do this audit query with corrections. And so when things have the same timestamp in valid time, it will then look and for that given timestamp show all the different versions in transaction time. And so if we run this one, we then see we have green, which was the first thing we put in, and that was replaced by blue. So the valid time instance are the same, but the transaction ID and transaction time are slightly later. And yeah, that makes sense. So transaction ID is a monotonically incrementing thing modeled by Kafka offsets if using Kafka. Otherwise, it's incrementing integer. Cool. So yeah, in addition to putting documents into the past and put them into the future. So if I take this and submit this, transaction 6, we now run another entity query. So the thing we put in was orange, but where is it? Where is orange? It's not there, it's not there, it's not there, it's not there. And what's happened is that because we're using DB, without specifying any arguments, DB automatically takes the view as of now. And because we put the information into the future, we don't have like visibility of it now. So if we want to see things in the future, we have to pick a point in the future in which to query from. So to catch anything else we might want to do in the next hour and a half or whatever, we can take a point, 2030, and take that point as a snapshot. And then if we query, again, the history, we will see that we have blue, red, yeah, foo, red, red, orange. So I haven't got with corrections here, otherwise I'd see the green as well. But yeah, you can of course combine these concepts. So anyway, putting data in the future can be useful for coordinating change. So like in that retail example where people are updating the catalog and the price information, and like these are all different teams, different systems feeding into like this one central place, which has to maintain something that someone in the business team can say, oh, what is the storefront going to look like at midnight on Boxing Day, Black Friday or whatever, Cyber Monday, and see exactly how the site's going to work. Like to preview all those changes at once, it's quite difficult. So I think this is a good use of its capability. So again, I'll pause, take a sip of water, and look at questions.
I think I have a complicated one. Is there a way to query a previous version of a current document? So, for example, I have a document with blue, and I would like to find from that document ID the previous version of that document, but
within the query.
Yeah. Okay.
Yeah. I think I understand what you're asking. So within the scope of a query, how can I see the previous versions of the documents? And this gets into, I guess, a limitation limitation is probably the right word. So the way we implement bitemporality is it's point in time based, and it's completely orthogonal to the data. So if you want to then query versions of the data in Datalog, you can actually use the entity history API and then plumb it into your Datalog query. So you can because you can call arbitrary Clojure predicates. So I can show an example of how to do that. Yeah, maybe I'll come back to that if we have time. But basically, yeah, within a query, you can like within a where clause, you can use a custom queue function, give it a database value, which is like the context database value, and then you have like another query inside here. Or if you want to call a custom function, you can say get all entities, or get all versions, say, for so given the database and given an entity ID, and then you can destructure those as like versions or something. Versions. Yeah. So it'll be something like that, and that's like one way to do it, but it's not like a first class part of the Datalog.
Yeah, that is very useful, but I have a explanation of my actual question. So, what is the way to get only the last version of my entity history?
The very last version.
Yeah.
The simplest way to do that would be to say, like if you don't want to get back like the full set of data, you could you could use open entity history. So open entity history is like a stateful thing. So you have to use a with open and do this kind of thing. Yeah, like that. And instead of ascending, we want descending. And then we need to call iterator seek, which converts the Java iterator into a Clojure seek on H, and then we can like, I'm trying to remember. My actual Clojure isn't great, so don't don't judge me too harsh. But it would be like a dual, into vector, something like that. And that's right, not dual, but we just want to we just want first, actually. Sorry.
To take the first, yeah.
Yeah, take the first.
And then not dual.
Well, no. So the thing is, because it's lazy, I think first will be lazy. So I think if you didn't do dual, it will break or complain. Or maybe it works. There you go.
No, it won't, because it's only one item and then you close it. So that's fine.
Okay, there you go. That's your knowledge of sequences, which is better than mine. But yeah, that's one way to do it. But yeah, be careful with using with open, because you got to make sure you consume the sequence before.
If you will not type first, then you will end up with a bad result without dual.
Yeah. Maybe we can just show what that looks like. I hope you know to see it. Or maybe because there's only one. I don't know. Anyway, or maybe it's because you're trying to print it or something. The point is just be conscious of it. But yeah, good. Sorry?
We have one more question in the Zoom chat.
Oh, in the chat, yes. Yeah, I did see that. It was about skewing right, wasn't it? Why isn't clock skew a problem with multiple nodes transacting instances generated centrally? Yeah, so it's a good point. So, like, what is the nature of the valid timestamp? Like, what governs that? And there is no answer that XT imposes. So it's completely up to you. So if you want to have like an atomic clock in your data center that's generating timestamps centrally and passing it out across your enterprise, and like you can use that as like a trusted timestamp source, which has very strict properties. If you have like clock skew or clock drift, then at least XT gives you the ability to go and make corrections. So like it really depends on use case. If you're integrating very different systems, which are in different parts of the world, different data centers, there's always going to be a few milliseconds difference. And so, like, I don't know exactly how you'd resolve that for your particular business logic, but there will always be a way to say, well, which one is actually needs to come first, and then you establish the actual like business time, because from one of the reasons that motivates these databases, and I haven't really talked about like bitemporality in industry, but if you're in insurance or in finance, you have a real regulatory need to track and like come up with what is the canonical view of time, because that is what the regulators want to discuss. When they're looking at your books, they don't really care that, oh, this data center's over here and has a slightly skewed clock. So you've got to figure out how to resolve that and present this single view of time. And this is also why we're not focused on like extra dimensions of time or forking time models. It's because for the majority of use cases, one central valid time should be enough for a business to like coordinate around. Hopefully that makes sense.
Great, yes, thanks for that. If you open up the Zoom chat, there's also a couple of questions about updates.
Oh yeah, is it possible to apply correction to an entity that we already deleted? Yeah, so I haven't shown you the delete operation, but essentially I'll just do it because it takes a moment. So if we have a submit n xt as well, if I show you this, it'll possibly break something else I want to show you, but maybe I'll create another entity. So if we create x, that will break that. We can always delete it. All right. Bump yourself, right? So xtid. Yeah, let's say put, right. So instead of put, we're going to delete this, and yeah, we can run this. No, sorry, we don't need to specify it as we don't specify the document. We just specify foo, like that works. But you can also specify a time range in here. You could have like start and end to delete, and it will delete that segment from the timeline. But let's keep it really simple and let's delete the current version from now. So if I submit this invalid TXOP, that's because it needs to be qualified. So yeah, that's worked. And if we open entity history using this guy, yeah, that's the one. So we see here that well, you can't, or is it doc nil? Doc nil, yeah, so this is delete. So doc, where doc is nil and the content hash is like a bunch of zeros. And so then if you want to correct that, like if we wanted to correct this valid time, we can basically copy this instant into our buffer and then a new version there over the top of that deletion. So n xt puts, and then we'll do foo in a second. But that's the time we want to put in. So this will correct the deletion and the value in from one of these. So instead of red, we'll have purple. Okay, and then if I run this one, we see we've got purple here now, and we don't see nil, but we would see nil if we add with corrections. And hopefully that makes sense. Right on now. Work. Yeah, I would have expected. Did I submit I put this back in so that we see purple and we don't see nil. I guess nils get coalesced under corrections, so you wouldn't see it. So you wouldn't see the fact that you deleted it. But if you need to record the fact that you deleted it in the previous version, or need to find that out, you can always inspect the TX logs. There's another API called OpenTXLog, which well, I won't do it, but it's like another iterator seek thing, and you would have to consume the log to find like that. The other way you could do it is if you still have the transaction like receipt, you can then I think you can call XT entity TX on it, and that will give you well, that work. Oh, yeah, maybe that wouldn't be a good way, but at least if you in the DB coordinates, if you put it in at that point before purple was inserted, before you corrected the deletion, you would still see the deletion. So like the queries will still respect that semantic, but the information is in some way invisible here. Might be another option you can add to this history call. So good question. Thank you.
So if an auditor was trying to do some kind of forensic audit, I guess they'd look at the transaction history rather than state of the database, because the state of the database seems like it can be manipulated with respect to what happened in what order.
Well, with corrections is supposed to give you the exact view of entries. So I think like this kind of logic has changed a bit over the last couple of years since we've been going. So I don't know if anyone's depended on that functionality existing before where it shows nil in here, but I think it's been coalesced out. So arguably we could either add another option, just say like show deletes or something with deletes. And it might be something, I don't think I have any colleagues on the call to help me check the source code in or the docs in real time, but I will follow up on that question and maybe post a comment on the video when this gets released.
Good idea. We do have one more question in the Zulip chat, in the Zoom chat, sorry. Can you do updates with functions?
Yep, so you can. Skipping ahead to transactions, we have this idea of transaction functions which execute serially inside the database. So if you need to do this as like a consistent change, you can do it. One of the caveats there, though, is that to do it truly consistently, but if there's like a huge database, you don't want to do it like all in one go. You wouldn't want to say read out 1 million ages. Was it age? A salary. Like you wouldn't want to read out all the salaries from the database, update them, and then put them back within a single transaction. You'd want to sort of chunk it, and then on your query side, you'd need to wait until the last chunk was written before you considered it like a valid change. And you'd probably want to use a different attribute or something as well to simplify that transition. That's probably the answer, that there isn't any idea of like a calculated attribute. So you couldn't add like, I now want to, there's no easy way to say, make all the values increase by 10% in a way that doesn't block the transaction queue. I'm not sure how you do that in a SQL database without blocking the locks and things.
By the way, we are a little bit over halfway through our 2 hours.
Yep.
Would you like to take a quick break now, or do you want to finish up any aspect of the current topic?
So I would be happy to pause for just if you want 5 minutes, I'm happy to. Equally, I'm happy to keep going personally. But I think in the interest of fairness, let's take 2 minutes then.
Okay, let's take a 5-minute break. I'm showing the time is 12:13. So 12:18, we should return. See you in a bit.
Great. Thank you. I'll reshare.
Welcome back from the break.
Yep. Thank you.
Just a reminder to everyone, you can post questions in the Zulip chat. So let's proceed.
Great, thanks, Mark. And hope everyone feels suitably refreshed. So, the last thing we were talking about was where the deletions show up in the entity history API. So I was going to take that as an action. So the next thing to discuss would be, well, let's try and put some color in all of this, because it is quite opaque to just see a list of entity histories. What if we could visualize that? So hopefully no one's cheated and already clicked on the TTVT tab. But essentially, there's a way to visualize this. We've got 2 axes of time, and I've already shown you sort of an illustration of what the diagram could look like. And there's plenty of resources which do try and visualize this. So, for instance, I saw this a few month or two ago. Someone was talking about SQL for data warehousing, and they have these examples of, well, if you have given this column with valid from, valid to, and other prices, other times, let's try and visualize it in this grid format. So, what I did was to essentially create some SVG rendering code which generates this. So in the namespace TTVT, I have some code to do this. I think if I just run this, we'll see some stuff already, because we've got a database full of things. And that isn't really designed for the number of transactions we've got. So it's a bit cramped, but hopefully you can see what's going on. So we've got transaction times on the x-axis and valid time on the y-axis, and actually this other website has it all the way around there, valid time on the x-axis, but I prefer to think of x being y being a function of x. So x is the input, but the actual transactions are the input, and the valid time is just a projection. So in this example, we're visualizing all the transactions we've just written. So you can see we've written one to the valid time past, and in this we're not seeing the one in the future. And if we read it left to right, we're saying, first of all, there was just one version of an entity, then there was two, and then you can't see it here because they're both red, but there's another version here which is red. But I'll just open up the browser inspector. You can see there we've got like another slither of red there. So there's two transactions where it's red, but we changed one of the other attributes. I forgot what it was now. And then we replaced everything with a new version. I think something like that. Well, we added colors to some, and ones that didn't have color, I've auto-generated the color. But if I was to, and you can see purple was the most recent one we changed. But if we add in that future timestamp again, so inst, let's go for 2030 again, 0101. Should see another row added to this. Oh, of course, I have to save so that it refreshes, so that Notespace knows to look at this form, then evaluate. Now we see another entry here. So yeah, see that's 5th of December up there at the top entry, and that's the orange, which is correct. I think that's what we discussed before. Orange was somewhere in that list. In the future, well, I don't know. Anyway, we can play with this, and just to give another illustration, if we go into the namespace, so into TTVT, I have I copy that sample data from this table and dumped it in this format. And initially, I started writing this for using the JSON API, or so people could trivially use it, hit the HTTP endpoint that XT has and paste the data into like a browser tool. So I was focused on browser rendering and coercion from the JSON formats. So this data is in like slightly different, doesn't have the qualified namespaces, and it's got uppercase snake casing going on, no, camel casing instead of snake casing. So now I have a function to transform that for proper Clojure usage. And if I was to now, the way Notespace works, you can actually switch between namespaces, so it's a little bit interesting like that. I think, well, if I put this here and I try and run this, there you go. So it's now changed namespace to VTTT. So in this trivial example here, where I have blue, pink, orange, and red, and where I've used the word fill, it's picking that up and putting it in as like text. Maybe in one day this could show like the full document, or as you mouse over the different sections, it could show you which document it is valid at that point. Yeah, we can see blue has was the first transaction at the first valid time. So again, valid time is on the y-axis. Then it was pink. Then orange was in a later transaction, but red was in the first transaction. And here we see orange replaces red. So from a like, what is the current state of the database? It's from valid time 2 and 3, it's orange, and 1 to 2, it's pink, 0 to 1, it's blue. And yeah, obviously simplified it to not use timestamps, so we can use string number comparisons. But yeah, feel free to have a play with this, and I've got another sample here which matches the diagram on this site. So if I put them side by side, you'll see that they are the same. It's just inverted accordingly. But yeah, I think that was a nice achievement to see this, because initially I started working on Skittle that Borkdu created to like do like a bookmarklet thing, using Sci in the front end to generate something. But here we're using backend Clojure to generate SVG, and it's rendered on the front end. So nice full circle. So there's some functions here to do stuff with ClojureScript as well. Anyway, so those are some examples of seeing history. And if I go back to this namespace and save or evaluate, I'll take it back here. So yeah, I'll pause for questions. Anyone have any reactions to that diagram? Does it help clear things up? Does it make sense? I hope so. Cool. Moving swiftly on. So we have one other way to sort of think about the constants of the database. And of course, this diagram we're looking at is just for one entity. So imagine you have millions of entities. Your queries need to be able to navigate across these. But even just to reason about as a human in a small scenario, if you have 5 entities with complex histories and you run a point-in-time query to sort of sanity check what's going on or to have a visual model, this isn't good enough. You need to have like a multi-dimensional projection like this or something to visualize it. I haven't got one of those handy. But what I do have is this idea of let's put it all into a table. So if you were to imagine the XT data as like one giant relation, so there's only one table in the database and it has everything in it. This is how things might look. And I didn't manage to get this working with, I think there's a tablecloth way to display tables, but I didn't get this working, unfortunately. But if I go to universal relation, and if I just put a simple example, and I'll also open my REPL. Yeah, so I can show you. So if I yeah, buffer, yeah. Okay, so if I now, so I won't explain what the function does, and it's kind of ugly in the sense like I'm going through the transaction log and then like looking up all the entities. Yeah, that's a really badly formatted thing. Going through all the entities and then all the history for all those entities and then combining it into one table. So this really is only practical for like small visualizations of like tiny in-memory databases, but it gives you an idea for at least the mental model I have for thinking about how XT works with these timelines. And so if we actually attempt to run this for the small example here, we have a table with the transaction IDs, transaction times, the start time, and here the start of the next thing is implicitly the end of the previous one. So in this case, the valid time start of this row governs the end of the validity of the middle row. And then in the columns, there are various databases which have this idea of like columnar storage or sparse column storage. And things like Cassandra and HBase, they're these wide row concepts. And this is sort of like a way to think about XT in those terms, where this universal relation has a wide row, like entity foo has attribute A, but entity bar doesn't. So instead of displaying nothing, because nils are valid values in XT, I've just got this sort of placeholder XT nil, but that could even potentially be an empty thing, like an empty slot, but it's just to make the table display. But this is the other way to conceive of things. So if we were to apply this function to our data set that we've been building up, yeah, I think all we have to do is run this function. I will save this, evaluate this whole buffer. Yeah, print it. Yeah, so I mean, this is it actually. So we can see we've got all the transactions we've made. So transaction times are all, because I've reevaluated the whole buffer, the transaction times are all clobbered, but the valid times should be about right still. So we still have things that were done now, things done on the 1st of December, and things done later. And actually, I think I've just found a bug in my code. So here, where we're doing a looking at the entity history, we're not looking at the future history. So actually, this isn't pulling out the stuff that is viewable from 2030 perspective. So I can probably edit that alive and entity history. Yeah. So here, if I added inst. Again, really sorry about formatting this code. 2030. There we go. Reevaluate that. Here, reevaluate this. Yeah, so these are the entries and they're ordered by transaction time. So you can really think of this as like the log, and we're only ever appending entries to the log. And where we've got a blank, that is like an implicit delete. Those are the deletes, I think. Yeah, this is not a perfected tool. I just wanted to share this visualization with you in case you wanted to play around and get an understanding of your own data. And XT does have a UI endpoint on the HTTP console, which we can have a look at. And Tatu, I forget his actual name, the username Tatu, T-A-T-U-T, he wrote the XTDB inspector tool using a really interesting UI library, which pipes results over the WebSocket and renders it on the front end. But it means like all your server-side code, like creating static renderings, which are like dynamically updating the front end. So you're only having to write server-side app and not having to worry about Clojure script. So I think that's really promising. And so I'd actually quite like to try and integrate this visualization into his tool at some point, maybe over Christmas. Anyway, so that's enough about history. I'm now wanting to switch gears and just talk about, let's back up a bit. Like we've gone deep into data model stuff. Let's talk about storage. And if you want to get a RocksDB database so that your data actually persists, how that works, and then put some graph data in it, run some queries over that, and then we'll probably be done for time. So I'll pause for a second more and see if there's any questions. Cool. How would you model time series when queries always go through historical data? Yeah, so it depends on the type of time series you have. So as mentioned, Datalog like doesn't always have all of these smarts that like SQL does for running time series like queries, especially with like windowing and statistical functions. So generally what you do is have like some Clojure code which does some analysis, like pulling data out of XT and then like doing some processing and pulling out a few more values from the indexes, or like via queries, like small queries which pull out just individual things, like streaming them out. So that's a pattern. Looking ahead, like this is actually a use case we want to explore more, because there's a big difference between temporal data and like time series data. Time series implies like very fast write throughput. Like maybe you don't really care about transaction consistency, or like queries being eventually consistent. So there's a lot of different trade-offs between something like trying to think of time series databases. They all escape my mind right now. But yeah, there's quite a few which I'm sure people use, and yeah, they're really optimized around scale out use cases. Whereas temporal data, we're not really trying to support like billions of updates of ticket data, coming in every hour or something. Like XT isn't working quite at that scale. I think it could potentially get there in the future, especially with some of the engineering work that's going on behind the scenes. And it's worth mentioning that if you like look at, I don't know who's watching the repo or like monitoring development activity, but a lot of work is happening outside of the XT repo at the moment on sort of the new architectural infrastructure and relational and algebra engine, which we hope to bring online next year for everyone, which will make more sort of interesting time series queries available and make them more practical as well from a SQL perspective, because we don't want to boil the ocean and get everyone into Datalog unless we have to, because I think there's an intersection between like if you're comfortable with Clojure and Datalog, like XT is a really natural thing, but if you're not prepared to use Clojure, things just get quite complicated, like to do aggregations over time series data, for instance. There is an example in the repository called TS weather and TS devices. I forget which one is probably the best one to show you, but these timescale, that's a good example of time series database. I think this is the one that integrates into Postgres, or extends Postgres. But yeah, if you want to run this kind of query using XT, like you can do certain things like this, and I think that's quite a simple lookup. This one's a bit more complicated, and then this kind of thing, you're running quite a few small queries. You're looking up entity history multiple times, like you're basically doing in-memory joins and not sort of doing things through Datalog, because Datalog just isn't expressive enough to like describe this kind of query. But you are using valid time here, which again isn't optimized in quite the same way. Time series databases are like, let's get the smallest number of bits possible. There's no real indexes in time series databases. We're not in the same kind of scale that we're looking at with XT. So there's trade-offs, right? So time series data is high throughput and probably isn't a good fit for XT. But at smaller scales, if you don't have terabytes of data, or if your data volumes are never going to grow to many terabytes, XT can be a good fit, because the underlying indexes, RocksDB and LMDB, can eat up as much local disk as you give them. It just gets a bit more cumbersome to do operations with huge databases and expensive. So that's one example. And then the other one is TS devices. Which is here. And we use these for our nightly bench runs. So anytime we make a performance change, we use tests like these, and there's others to just sanity check the entire like IO story. Are we using caches efficiently? Have we broken APIs? Everything. So yeah, more examples. Open entity history. Got some merge sorting going on. Laziness. Yep. Cool. Hopefully that gives you a feel for that kind of thing. As I say, big priority for the future is to make these easier. Great. Okie doke. So next, RocksDB. So if you want to store data like actually on disk, you really need to have a durable transaction log, a durable document store. The index store, which is the third component that's embedded in the node, that arguably could still be in memory, but you may as well just persist it, just so you get a feel for what it would be like in production. So basically, having everything in memory is really just for testing. So if we go to the XT site, we see in the docs, and if we go to configuring, it talks all about the modules, the different storage options we have. So ROX and LMDB are good for index stores. We can also use the default one. So whilst it's possible, it's not necessarily what we recommend for prod. And then one of our partner organizations, Visi, they have developed a key value store called Exodus. On top of Exodus, they've built like a key value abstraction that XT needs. So they're all implemented via Clojure protocols. So implementing a new index store, document store, transaction log is like a really well documented thing. So if you need to customize and have like something specific to your cloud, like platform as a service environment, and use some database as a service behind the scenes, you can do that. But in this case, we're going to use RocksDB. So if I click on Rocks, it tells us all kinds of instructions about how to use it. So we're using Clojure, so we can use this kind of setup. So what I can do is just copy and paste this into here. And so that's our configuration map. And I can say XT start node. Now we need to fill out a few more details before it's ready, but we'll call this one def n2 just to access. Yeah. Anyway, right. So it says to use file abstraction like that, but I think, well, I might just import Clojure.java.io. Java. I think that's what I need to do. Is it created? I can never remember. does it require? Cool. So then we should have IO file, and we can use the temp directory. That's fine. But what we can do is then copy this and use a separate RocksDB instance for not this one. This one. Use a separate RocksDB instance for the document store and the transaction log. The reason you want to do that is because it means that you can delete the index store. Like if you're doing an upgrade to XT, you need to wipe the indexes. You don't want them to be coupled together. But if I zoom out a second, you'll see actually we're using the same name. So we want to say maybe index be docs. Okay, and I'll see if this works. No idea if it will. File error knows its namespace. Right, so I need to do that as IO, don't I? I guess it's worth pointing out at this stage as I'm not. Right, here we go. Yeah, so that worked. I don't know if you saw that. So it's going to compile again because the lock held. In fact, I've just ruined it. So I'm gonna basically, I've just lost the reference to N2. So I'm going to create a new node. So there we go, N2. And just like before, we can run XT status on N2 and see a bunch of version information. And if we go back to here, and if I press save, here, you see here it says pretty printed. We've got rocks KV, number of keys, and it has like a default size just because there's various like log files and stuff which rocks creates when it starts. But that's it. So now we have something which we can write some data into. So if I went, if I did submit on N2 and put in so vector transactions, XT put, and then a document, and let's call this one. So we can use a keyword ID here, doesn't really matter, and maybe I'll just put in foo bar for good measure. So if I submit that, and then run status again, I'll see it's got 17 keys, and these aren't keys in the documents. These are like key value keys. So for all of those indexes I described earlier, like this document which has 2 fields and 2 values, plus the temporal indexes, plus the various combinations, we're generating 17 entries, or maybe 16 because there was already one in there, I think. And if we submit another one, we'll see that number increase. And obviously the size of the disk as well, which is the kilobytes. Oh, sorry, bytes rather. So if we run status again, yeah, we now have 33 keys. So yeah, it's about 16 keys for each of those documents, and the size in bytes. Yeah. Cool. So now I have a node. I can close it. So I think, yeah, we'll complain. I can just put closable there. Stop my editor from. Actually, no, I won't, because then I have to import it. Anyway, I'll just run it and it'll be closed. Right. So now if I try and run status, it says XTDB node is closed. So to run it again, all I have to do is run the exact same configuration. If I was to change the configuration and like try and use a different transaction log or document store, it would be a fundamentally different database. So the database requires these two to be the same, but the index store could be different. So if I was to change that to 3 and then start it, it's going to be a completely different RocksDB index store. So the first thing that when the node starts, it's going to download all the transactions from the transaction log, pull in the documents it needs, build those indexes, and then the status of the node will catch up to be exactly the same as the previous one. But these are 2 different stores. And if we were to look at the temp directories, we'd see the 2 different folders or directories. Yeah. So yeah, so that's essentially how you do an upgrade. in fact, it's actually better to use a different path rather than deleting the index and rebuilding it if you're doing like a stateful deployment. Obviously, if you're using Docker and Kubernetes and these things, you'd never restart a node. You'd kill it and use a different disk or whatever. But if you're doing anything with stateful disk usage, yeah, lots of things here to be aware of. And if this module system for starting the node is quite extensive, like it is almost as feature complete as Integrant or Clip or one of these other tools. So you can put dependencies between things, and if you want to customize caches, or like RocksDB has like a concept of a block cache, so you'd like configure it not there, configure it here. So I can't remember exactly what it is, but it's going to be like RocksDB, maybe it's XTDB, but RocksDB block cache. But anyway, it's not important. But the point is, you can configure the indexes, and like if your queries are slow, like maybe you want to increase the cache size because by default it's quite conservative. Another thing is, it probably doesn't say it here, but like there's like an environment variable which tunes the RocksDB configuration. ElementDB is a lot simpler in a way, so there's like less machinery, less layers of abstraction, so you may have a better time with that. Queries can be faster, but it's not as like used in the industry. So like Googling for errors and that sort of thing might not be as easy. Cool, so that's configuration of storage. If we wanted to use Kafka, it's like basically instead of this map here, like txlog, we would use, instead of it being a KV store, we would use Kafka like this, basically. And Kafka has these property files, and we can specify things in a properties map. So like properties map or something. And then like point to the properties map location, and obviously configure various other options. Stuff as transactional, that's not good. So that's another example of configuration, but I don't think we want to be booting up a Kafka cluster today. Well, I did see there's a company that does Redis hosting called Upstash.com. They're just bringing on a competitor to Confluent, so that space is heating up. Confluent Cloud, that is. Cool. I don't think there's anything else to say on that. JDBC is a bit more complicated, and getting it working with like getting Postgres booted up and creating the users or whatever. But yeah, it takes a JDBC URL and uses Next JDBC under the hood by Sean Caulfield. So yeah, it supports various backends, and you just need to include the driver to use it. Okay, I'll check for questions and then move on to the next topic. Java line closable, thank you. That's right. Okie doke, so let's close a few things down. Actions. So we looked at storage. The next thing to do is look at some graph shaped stuff. So I think it was last year's workshop where we downloaded like a movie database data set. That was really extensive. But in the interest of time, especially, I won't do that. But you could fill RocksDB with like 300 megs worth of data from, I think it's from Kaggle. We have some code to do that if you want assistance with that at some point. But like we can just take a very small set of data here, and rather than using Nextjournal, as great as it is, we'll use our REPL. And probably could find this on my file system somewhere. This is here. So I can take this data, paste it into our, close the in there. So if I paste this in here, you can kind of see there's a, what's the word, a schema to this data. So we've got people, so James Cameron, Arnold Schwarzenegger, bunch of actors basically, But in here, there's also directors, and we have no way of knowing without looking at other data, other documents or entities, which of these people are directors or actors. So we have a bunch of people, and they're in the sort of these are just negative integers, which are valid IDs. They don't really mean anything because they're negative. And then later on, we have information such as some films, and those films specify the director and they specify cast and sequels. I don't think I've seen a query use sequel yet, but anyway, we have that information, and we also have a year, so we could potentially use the year to put things into valid time past if we wanted to really exercise the temporality. We're not going to do that for the moment. And yes, so we have these movies from the 80s and early 90s. And somewhere on here, I will, if I save the document, it should show up on this thing, note space, and then I can transact it. So I'm just going to copy some functions from here. So in order to submit those documents, I'm going to take this and I'm just going to change the node to use the node that we just created, which is N2. And yeah, you see it's mapping over all of those documents and putting them as different operations in the same transaction. So that's the first time we're looking at different transactions, like single transaction with multiple operations. And there's all kinds of things to be aware of in transaction execution. If using transaction functions, they have a view over like the intermediate operations that have been applied, and if you have a match, then the thing terminates early. So you can add like these constraints on write to ensure consistency, which are like endlessly configurable because you have full power of the entity history or Datalog API within the transaction function. And transaction function is like a memoized thing that executes once or roughly once, and then the result is persisted into the transaction log and document store. And that means that all the nodes have like a serial view over these like arbitrary functions. And I haven't even mentioned eviction yet, which is this other key concept which makes things like replaying logs hard, because if you start poking holes in your document store and saying, no, this is a tombstone, this is a tombstone, you have to build up some state and know that that state is roughly consistent with what it should be. And it can still like move forward, even if it's like missing some data that was used by a function, because if we cache the result of that function, then the eviction happens later. So there's all kinds of things to think about. The documentation does cover some of this, and there's plenty of chat logs to read and look through as well. But I'm always happy to have questions. Anyway, it's right. So let's submit this data. So this is the second transaction. It's going to be a big chunky transaction. I reckon if we looked at the, I'll be flipping back to the other storage, but we can just have a quick poke at what the index size is. So now we see it's got 13,000 keys, and it's using up 200 kilobytes. So it's not massive, but it's not tiny either. Well, not completely tiny. Right, and it's quite hard to scroll through. Shouldn't really be scrolling. Right, so submit TX. So we've done that, and now I just want to show you a query. So I'm going to skip through and show you like an example of a fairly complex graph query that we can run. And this tutorial is good. And there's a couple of other tutorials as well, which I'll signpost you to. But if you're just interested in learning Datalog with XT, this is a good resource. So we can do things like, given a director and an actor, show me all of the movies they work together with. So here we can pull out Terminator 2 and the Terminator. And we know this by traversing between two different people, which both have a name. And so we're using different logic variables here to bind to two different people, and then traversing a graph from director to actor through a movie, and that movie has a title. So we're projecting on the title to find the title there. But we could basically copy this exact query and run it on our REPL to show what it looks like querying rocks. So all I need to do is do XT query that, and then I need a DB, so DB of N2, and this needs to go inside of the query as well, because these are query parameters, and I haven't really explained Datalog in any depth. But yeah, what we're doing here is like a relational destructuring of these input tuples. So yeah, we get the same result. So hitting our database at the current point in time. And if we did want to set the database to, instance, let's pretend we could access the database yesterday and there was nothing in it. Nothing. So there you go. Small example of a graph query there. And if you want to run a graph algorithm like a Kevin Bacon, nearest neighbor, or a shortest path between two nodes in a big graph, you can do those sorts of things as well, but it involves, again, dropping down into Clojure and doing like a breadth first traversal in memory, or maybe you spill out to disk. But essentially, if you want to do like graph algorithms like Neo4j has, it's a bit more code. Datalog doesn't do it natively. And you can use custom functions as discussed. So you can say, show me all the people whose name starts with M, and we get, an unordered set of people. And what else have we got? We've got aggregations. So you can do counting and what's the minimum, what's the maximum. There's been some chatter on Clojure and Slack recently about the efficiency of count operations, because basically it doesn't leverage stored information in the indexes. The indexes have to be scanned to do counts. So again, sort of space-time trade-offs, whether you want to store these sorts of things ahead of time and use transaction functions to maintain them. And I'll just mention rules briefly before wrapping up. So rules abstract the clauses, and then you can call those clauses multiple times using a single rule invocations. And if you have mutually recursive rules, they're calling each other. And so here we're saying we want to abstract over the idea of a cast and a director relates to people. We just want to have a single way to relate those two entities, and that is called associate with. So again, we can use that sort of thing to build simpler looking queries. The actual execution of those queries may not be as efficient as if you were to, drop down into Clojure and do some of these things more manually. But it is a reasonably expressive. You can do a lot of complex stuff. Cool. All right, I think that's about it. There was some other things I wanted to talk about, but as ever, there's never enough time. The ability to evict data, the ability to speculatively write transactions. So you can say, what would the database look like with these 10 things inserted? And you don't actually have to put them in. We've got the full text search index. So you can do some fairly configurable things, like you have full access to the Lucene API, and you can stream out the results, merge them with the temporal indexes. There's the whole namespace dedicated to that. And a couple of users, the Egeria project, which is a Linux Foundation thing, some of the contributors to that have been using XT as a backend for this metadata graph service thing, which is what Egeria is. And so they're using Lucene. In terms of actually running XT, there's a monitoring system and all kinds of things to understand about how to scale up nodes horizontally, because it's possible. But depending on what your infrastructure is and how fast your documents store and the network connectivity, there are all kinds of trade-offs to think about. But I think that's about it. So I will say thank you very much, and I hope everyone has a wonderful rest of Reclojure. It's been a great privilege to put this on. I'll stick around now for any questions or just chatter people want to have. I don't have any hard stop. So thanks, and thanks Mark for hosting.
Wonderful.
And Daniel for putting this note space together. It's awesome.
Absolutely. What a great tool. So thanks everyone for attending.